All right, we are going to do a little bit of a review on the topics covered in Math 10C on the idea of trigonometry, so that we can continue on with our 20-1 content and feel confident in our skills. So in Math 10C, we spent our time looking at 3 primary trigonometric ratios. So we called those ratios sine, cosine, and tangent. And a reminder, a ratio is just a comparison of 2 things, and then we usually represent it as a fraction, right? 2/1 is a ratio saying the top is 2 times larger than the bottom. These ratios, what they do for us is they tell us that for any given angle in a triangle, right, if we choose a specific angle in a right triangle, it's going to compare how 2 sides of a right triangle are related. So how much longer is one than the other, right? Is one twice as long? Is it half as long? Is it 3 times as long, right? It's going to be a ratio comparing 2 sides. So from a given angle, and the general idea we use for an angle that's unknown is we call it theta. And that's just the Greek letter that we use to represent usually an angle measurement. So from a given angle, when we're talking about these sides, we want to label the sides as either the side that is opposite the angle we're trying to find, the side that is adjacent to, right, or beside the angle we're trying to find, or as we have in every triangle, there's the hypotenuse. That's the longest side. It doesn't matter what angle we're looking for. The hypotenuse is always the side opposite that right angle, right? It's the longest side of the triangle. And the reason we want to label these sides in reference to an angle is because those are the sides that our sine, cosine, and tangent ratios use, right? Thinking that if I decided to look at this triangle from a different angle, so I decided I wanted to determine some comparisons from that top angle, the sides are going to change as well. Opposite is now that bottom length because it's opposite the angle. Adjacent is now that left length. And hypotenuse doesn't change because hypotenuse is a specific length in a triangle. So the ratios are as follows. The sine ratio of angle A or of angle theta, right? This is an angle spot. The sine ratio of an angle compares how long is the opposite side versus the hypotenuse. The cosine relates how long is the adjacent side compared to the hypotenuse, and the tangent relates from an angle the opposite side to the adjacent side. So that way all of our bases are covered. Each side is paired with another side one time, and so we can find out any ratio. We use the acronym SOHCAHTOA to help us remember this. So, the S being sine, the O being opposite, the H being hypotenuse, cosine adjacent hypotenuse, right? Adjacent hypotenuse, TOA being tangent, and then opposite adjacent. We always have the numerator first and then the denominator after. So what do we use these for? Well, just like any other equation, as long as we have only one unknown, then we can solve, right? Each of these formulas has place for 3 variables, 3 numbers. We have an angle, right, which we can call A or theta. And then we have 2 side lengths relating to that angle. We have the opposite side and we have the hypotenuse side, right? So if, say, I know the opposite length and the hypotenuse length, I would want to use the sine ratio to find the unknown angle. So again, if I'm talking from a specific angle, or let's call it A here, I first label my sides, right? From angle A, this far left side is the opposite side length. This close bottom side is the adjacent side length. And the longest side across from the right angle is my hypotenuse. Sine function tells us that from this angle, it says how long is my opposite length, right? How long is this side length in comparison to my hypotenuse, right? Is it going to be 80% as long? Is it going to give me a ratio of 0.8? Is it half as long? Does it give me a ratio of 0.5, right? How long are those side lengths for this specific angle? Because if we think, if I make an angle smaller, if I was to make A something much smaller, that side length, that opposite side length is going to get smaller. It's going to change our ratio. Or if I was to make A a really big angle, it's going to change that side length again. It's going to make our opposite side a lot bigger. So adjusting those lengths, those values, right? If I change the angle, if I make A, the angle here really small, notice that now the opposite is smaller and compared to the hypotenuse. So that's why it's always in reference to an angle, because the size of the angle determines how long some of the sides are. Cosine says take that angle, but now I want you to compare it to the adjacent side compared to the hypotenuse side. So if I'm using the cosine ratio, I'm comparing how long is the pink line compared to the blue line. The cosine ratio knows nothing about how long that green length, the opposite length, is. Right? That's why we have 3 separate ratios, because if we can only compare 2 things at once, I need 3 total fractions to be able to compare everything together. And then tangent, the last ratio, it says, well, how long is that opposite side, the green line, compared to the adjacent line, right? And in this case, it doesn't care now about the hypotenuse. We're only saying how long is the green line compared to the pink line. Okay. So if I'm wanting to find an unknown, and that's what we're going to do for a lot of these problem solving, each of these has 3 spaces for variables. I have to be able to fill in 2 of the 3. And so that's going to help me determine in a lot of situations, am I going to use the sine equation, right? Am I going to use this equation to solve for an unknown value? Am I going to use the cosine equation, or am I going to use the tangent equation? So let's look at some examples. So given triangle DEF, and again, that's just the way we name triangles from vertex or point D to point E to point F, the triangle created by those points. It wants us to determine angle D. So that is what I'm going to call theta. Or I can call it D, I can call it whatever, but that's my unknown. So because I'm working with angle D, I want to make sure I label my sides in relation to angle D, which means that this side 3 is my opposite side because it's opposite that angle. This side 4 at the bottom is adjacent because it's adjacent to my angle. And this length DF, right, from point D to point F is my hypotenuse because that's my longest side. It's the one across from the right angle. Right, make sure you're able to properly label these triangles. So now that I've labeled them, I need to decide, using my SOHCAHTOA acronym, which of these formulas do I want to use? Do I want to use the sine function, the cosine function, or the tangent function? And the way I'm going to determine that is I'm going to look at what do I have, right? I need to fill in 2 of these 3 things. I don't have an angle, so I need to have 2 side lengths, right? So it's not going to be the sine function, because while I have the opposite, I don't have the hypotenuse, and I don't have the angle. I have too many unknowns to use the sine equation. Same thing with cosine. I have the adjacent, but I don't have the hypotenuse, and I don't have the angle. But tangent I can do. I know the opposite length, I know the adjacent length, and so the angle is my only unknown if I use that formula. So step 1 is to write out the formula I'm using. So tangent of angle theta is equal to the opposite length over the adjacent length, right? And this formula is something you have on your formula sheet. But it may have x's and y's. But we'll get into that in our trig unit. I then fill in the blanks, and again, I need to make sure I can fill in 2 of these 3 pieces of information. And this time I can, right? I don't know the angle. This is my unknown. This is what I'm solving for. Right? Tangent itself is an operation. It's not an unknown. It's not a variable. I know the opposite length. I know the adjacent length. I'm going to plug in those values I know. So tangent of angle theta, right? Again, this is just saying what's the comparison? What kind of angle tells me that if I have an opposite length of 3 and adjacent length of 4, what kind of angle creates that ratio where the opposite is 3/4 of the adjacent? And then I need to isolate my unknown. So just like we do in every other situation, I have to undo whatever operation is being done. But the operation here is actually a tangent. Not a plus, it's not a minus. Tangent is an operation. And the opposite of that is an inverse tangent. And that's a button on our calculator. So I inverse tangent the left side, that leaves me with just theta. But what I do to one side of an equation, I have to do to the other. So I take the inverse tangent of 3/4. And so I'm going to pull up my calculator. Whoops. So I'm going to pull up my calculator, and we'll see what that gives us. So I have my calculator here. First thing I want to do, I need to make sure I'm in degree mode, right? So angles are calculated in a few different units. The units we're going to use are degrees, right? It's kind of like setting your calculator to give your answers in centimeters instead of inches. So you can go to mode, and you need to hover down. It's going to have radian highlighted. You need to go over to degree. If you have a scientific calculator that's not a graphing calculator, there should be a mode button as well. And if you have a Casio calculator, you're going to go to options and then see until you find that angle measurement option to change that to degree. If you're not in degree mode, none of your answers are going to be correct. None of your answers are going to make sense. So that's our first step. Then we go back, and so I said I have to take the inverse tangent. So notice here on my tan button, if I hit that, after I've hit the second option, it gives me a tan -1, an inverse tan. Right, and it's going to be the same on any calculator. Hit your second button, and then I need to take the inverse tangent of 3/4. If you have a Casio, you need to write those brackets in yourself. And it tells me the value of that, right? The angle that would give me that tangent ratio is 36.9. I'll round to usually 1 decimal place. So theta equals, right, I was solving for an angle, 36.9 degrees. So all that means is that if I have a triangle where the opposite length is 3 and the adjacent length is 4, or in general, if I have a triangle where the opposite length is 3/4 of the size, right? Even if I had numbers like 75 and 100 in those spaces, right? If I'm scaling up a triangle, either way, the angle has to be 36.9 degrees to create that relationship between the opposite and the adjacent sides. So there's our angle D. So that's how we find an angle. What if we need to find a side length? So we're here trying to determine length RS. So that's the length here going from point R to point S. Again, we want to label our triangle. They've given us an angle this time, so let's use that as our angle of reference. So from the 15 degrees, my unknown side is my opposite. This bottom side is my adjacent. The longest side is my hypotenuse. Again, I'm going to decide what function am I going to use. I need to make sure that my opposite side is included because that's what I'm trying to find. If I choose an equation that doesn't involve the opposite, how can I solve for it? And then I know the adjacent, so I want to use as much of the information as I'm given. And I know the angle, so I'm going to use tangent again here, right? Again, because I want the opposite and I know the adjacent, I don't have enough information about the hypotenuse to use it either way. So we're going to use the tangent function again. So tangent theta is equal to opposite over adjacent. I would always just start by writing your generic formula without anything in it. Now we plug in the values. This time we know our angle. It's 15 degrees. We don't know our opposite side. I can call that x. We know our adjacent side is 25. So again, same thing as before, I need to isolate my unknown. Right now the x is being divided by 25, so I multiply both sides by 25 to undo that operation. So now what I'm doing is I'm taking 25 and I'm multiplying it by the tangent of 15. And this is something I can just type into my calculator. I'm not doing an inverse tangent this time. I'm not trying to isolate anything. So if I just hit that regular tan button without hitting second first, and I do tangent of 15, all right, this essentially is telling me the ratio of if I had an angle of 15 degrees, how are those two sides related? What's the decimal value? And I was supposed to multiply by 25. And so it tells me 6.7. So x equals 6.7. And then we look for our units. It was centimeters before. So our other side length will also be centimeters. Right? And that means if I have a triangle of angle 15 degrees, and right, this triangle isn't drawn to scale. 15 degrees probably looks more like this. It's a pretty small angle. Right? It makes sense for the opposite side to be much shorter compared to the adjacent side. So it makes sense for us to have a value of 6 centimeters as my opposite when my adjacent is 25, much longer. So that's how we can find a side length when it's unknown and it's on the top of a fraction. So in this situation, given another triangle RST, I'm now trying to determine length ST. So again, we think about the information that we're given. I'm given an angle at S. I'm going to use that angle while I label. My unknown is ST, so that's my side up there. I'm going to label with respect to the angle I'm given because I want to use that information. This 15 would be the opposite side. RS along the bottom would be the adjacent. And my unknown side is my hypotenuse this time. So if I'm trying to decide, again, out of SOHCAHTOA, if I'm trying to decide, do I use sine, cosine, or tangent here, we want to think about the ideas that I need to include the hypotenuse, right? Because I need to find that. So that means tangent is out of the question. Tangent doesn't relate to the hypotenuse at all. And then I'm given the opposite side length. Well, I want to make sure I'm using that. Cosine doesn't use the opposite side length, but sine does. So I'm going to use my sine function here. So sine theta is opposite over hypotenuse. So plug in the things I know. I know the angle, so sine 35. I know the opposite length, so 15. And now my unknown is on the bottom of the fraction. So if I'm trying to isolate x, I need at the end of the day for this to look like x equals. So I need to move x to the top of the fraction. I would say the first thing we want to do is multiply both sides by x because we don't want x to live in a denominator. We want it to be up in the top. So I have x times sine 35 equals 15, but x is still not by itself. So now I divide both sides by sine 35. So x is equal to 15 over whatever value sine 35 happens to be. So if I pull up a calculator, let's say sine 35. All right, and again, that's just telling me the ratio at a 35-degree angle. But I have some information. I know that I'm actually doing 15 divided by sine 35. I'm going to do 15 divided by my answer. I can hit second answer, or you can type that sine 35 in on the bottom. All right, just make sure that the 15's on top and the sine 35 is on the bottom. So 26.2 if I'm rounding that. X equals 26.2 centimeters. And we always want to verify our answer. Does this make sense? Is our hypotenuse the longest side? Yeah, right? It should be longer than the opposite. It seems like a reasonable number. And one last one. We'll try out one more ratio here. From my angle, I'll label my opposite. I want to be extra careful here. My hypotenuse is on the bottom. My adjacent is here. And I want length ST. So I want my hypotenuse I have my adjacent. I'm going to use cosine because cosine relates the adjacent to the hypotenuse. I plug in my values, cosine 48, 24 over x. Same thing we did before, the x is going to come up to the top when we multiply, and then we divide by the cosine 48. That's now going to show up in the bottom of the fraction. So I go to my calculator. I'm going to do 24 on top, divided by cosine 48. And I get 35.9. So x equals 35.9, and our units on these ones were actually inches. So if you're feeling like you need some more practice on basic trigonometry, you have some extra practice on the back of this booklet on finding side lengths and finding missing angles. But going forward, we're going to use a lot of these skills in our 20-1 topic, so make sure you're feeling confident on your ability to solve some basic trigonometric problems.